Okay, go to the front cover here. Bad triangles go to prism. Anyways, make sure your phones are put away. Okay. I know it's tough. I know you're not feeling it, but we need to get through it. Okay. Triangles. We're gonna start with triangles. We're gonna talk about properties. We're gonna classify them. Put a little label here. We're gonna name them. Okay. Solving problems and sketch. Okay. Quadrilaterals. Then we're gonna move on to the four-sided polygons, and then polygons in general later, like pentagons, hexagons, and so forth. Okay. That's what we're gonna be focusing on in this unit. So let's go start with triangles. A lot of review here. Okay. Symmetry. Symmetry means that you can split it in half. You can split a triangle in half and get both halves that are the same. So for this one, okay, if this is 70, guys, we need to focus. I notice a lot of you are having conversations. Let's focus, okay? I need to get through it, or else you're wasting my time. I don't want to waste your time. Please don't waste my time. Okay? It's a bit of a crazy day. Here we go. We know that this one is symmetric. Why is that? Because we notice that both of them are 50. Okay, 50 and 50. Another way of indicating that these two sides measure the same is what? It would be the marking. If you have a marking like this and this, that tells us, it guarantees us that these two sides are the same in length. Okay? Which means that we can split it in half. Is it okay to go 35 up here? Is it? Yeah, it is. Okay? So it is okay to go divide it by 2 and make this 35. It is okay to do that. This is 50 centimeters because we're just copying that. And what's this angle here? If we're splitting in half, we are having a 90 here. Okay. And what do all angles add up to in a triangle? 180. The sum of angles in a triangle is always 180 degrees. Okay. So what would this be here? This would be 55, right? 55 degrees. Because I knew that this was 35, I could immediately assume that this is 55. Now you have all angles there. Do you remember sine law and cosine law? We're not going to necessarily spend a whole lot of time on that. I just want you to know things about triangles, okay? I'm not going to do the rest here. What kind of a triangle is this one? If you look at the numbers. This is 100. This is 100. Yes, this is an equilateral triangle. What do we know about all angles in an equilateral triangle? All angles are the same. And what do they actually measure, like in terms of degrees? If they're all the same, if you split 180 in 3, you get 60, right? Every angle is 60. So 60 degrees would be the interior angles. So you can grab this one and say that this is 60, this is 60, and the top here is also 60 degrees. So equilateral, it's a very unique opportunity for you to find out a lot of information about a triangle. What's the one up here called? This one is an isosceles. Please write it down, isosceles. Okay, two sides and two angles are equal. That's another note that I'm going to add to this. Two sides and two angles are equal. That's isosceles. What is this last one here? When we look at the side lengths, are they the same at all? They're all different. Anybody know what the name is for this triangle? It starts with an S. Scalene. Have you heard of this scalene triangle before? Maybe not. I don't think a whole lot of you. This is scalene. And what does that mean? This is what it means, okay? All sides and angles are different. That's what scalene is telling you. A scalene is asymmetric. Okay, so I'm going to write that word down. Oops. Asymmetric, meaning none of the sides are the same. So you can split this one. Can split. Okay. So you can't just say, oh, there's 100. I'm going to split that one. I'm going to cut it here and make it 50. That would be wrong. Okay. I will put 50 here, but make a big X there. That is wrong. You cannot split it. End of story there. So I just introduced you the three main types of triangles that we're going to look at. Scalene, isosceles, equilateral. What do you know about equilateral? As soon as I say the word equilateral, you should be thinking 60 degrees. Okay? 60, 60, and 60. Okay? You cannot change that. Okay, let's move on. I'm going to skip a bunch, and I want you to add these formulas to your formula sheet on page 3. Area of a trapezoid, area of a parallelogram, area of a triangle. That one you probably all remember. But these, and don't make them take up too much space. Okay? You want the study sheet? All right, let's go over to page 4. Pythagorean theorem review. I'm going to give you the like a crash course on it, okay? Pythagorean theorem. It essentially states you take the hypotenuse, you square it, and that will be equal to the other two legs squared and added up. That's what Pythagorean theorem, in a sense, is telling us. There are two cases to consider. Okay? Hold on here. If the hypotenuse is unknown, you will use this one. Hypotenuse is equal to square root of leg squared plus leg squared. That's the one you use most often. If one of the legs is unknown, folks, if you don't know this one or this one, where's the hypotenuse always located? It's always across from the 90 degree. So that is the slanted, that's the hypotenuse. So if you don't know one of the legs, which are the straight sides here, we just go like this. Leg is equal to square root of hypotenuse squared minus leg squared. So that's another review on Pythagorean theorem. These are the two versions of that formula. And let's see if I can quickly review this with you. This triangle right here, what's missing, hypotenuse or leg? Yes, hypotenuse. Hypotenuse question mark. So guess what? We're going to go A is equal to, what does the formula call for? Is just take both legs, square them, and add them, right? So this is a leg, and this is another leg. Doesn't matter which one you grab first. 7.6 squared plus 9.4 squared. You're not going to use this a whole lot, but if it does show up, I want you to be able to use it, right? So careful here. 7.6 squared plus 9.4 squared. You do that first. So that essentially gets you to this point, 146.12. And then you take the root. So A is 12.09 centimeters. Okay. It should always be the longest side, right? The hypotenuse. If you don't, then you're in trouble. Next, what's missing in this scenario here? Yeah, this is the hypotenuse. This is one of my legs that's unknown. Okay. So you use this formula. Let me see if I can have that on the screen. We're going to use this one. We're looking for x. So we're going to take hypotenuse squared minus leg squared. So you go 17.8 squared minus 12.6 squared. That's 158.08. Take the root of that. It's 12.57 inches. Okay. And now we get to the classifying part. If you want to practice this skill, you try right there on page 5, but I'm going to keep going a little more, okay? If we have time, I'll let you work through that. We're going to work with triangles, okay? Okay, make sure you make a note of that. Properties that are true for all triangles. It has 3 sides, obviously, no surprises. It's closed. The sum of interior angles is 180. And this is the one I would like you to add. Okay? Longest side will be across what? Largest angle. Can you see that? Let me zoom into that. Largest angle. So the shortest side will be across the smallest angle. If the province ever says, here's a triangle with all sides and all angles, and it's like, what's wrong with it? Check for this and check for if all angles add up to 180. That's the first thing I would check to see if you notice anything that's off about that, that's the mistake. I don't have to say that the middle side is across the middle angle, right? I don't have to say that here. That's the only other option. And here's where naming is going to be key. classifying triangles, okay? What does that mean? It means to give the triangle a first and a last name. Okay? We're going to go by angle measure and by what the side length is. Okay? So when it comes to angle measure, when it comes to the angles, you have these three choices. Acute, all three angles are less than 90. Right, what do you think is going to happen there? One angle measures 90. This one is so easy to identify. It's right there. Obtuse, one angle that measures more than 90 degrees. That is this one right here in this case, right? This angle right there is bigger than 90. 90 would be right there. It's bigger than 90. So these are your three choices, okay? Let's make an example here. So an example for an acute would be 60, 70, and 50. Right? This adds up to 180. And all of them are less than 90, okay? A right triangle, you just literally all you have to do is this. You just put a 90 somewhere. You can do it upside down even if you want. Okay? Boom, you've got a 90. Obtuse, all you need to do, I would say, put a number in. Instead of just making it look, just say 99 degrees. That's right there, that's an obtuse triangle. So all you need is one angle bigger than 90, it's in the obtuse category. You need one right angle, it's a right triangle. And if they're all less than 90, you're in the acute when it comes to, I call this like the first name, okay? Then we also classify them by side length. You have your three choices, which I just talked about it there. Equilateral, three sides are equal in length and three angles are equal in measure. Isosceles, two sides are equal in length and two angles are equal. Scalene, all sides are different and no angles are equal. I don't know why they couldn't just say all sides and all angles are different. Okay. What are all interior angles always? An equilateral. Let's see if you're awake. 60, right? It's always 60. Always. You cannot change that. Always. I wish they would just say that under the property, but they'll just say all sides are the same. Okay. Watch this, I wish I had time for you to actually build these things, right? But if you made sure all angles are 60, you would notice that all three sides would be equal to each other. Guaranteed. Guaranteed. Okay, that's a property that you can observe. With isosceles, okay? Let's see if you can follow me here. It's just another example. If I told you that this measures 10 centimeters, and what can we deduct by just looking at the markings? What's the length of this side? 10, yeah, just like that. And what do we know about the angles that are across from them, folks? They are the same, yes. So make a marking there. Scalene, watch this. The markings for a scalene that give it away is this. 1, 2, 3. Okay? One, 2, and 3. Another one that gives it away is if you have, let's make one that isn't obtuse right here. What kind of a triangle is this by angle measure right now? Just by me putting that box in there. It's a right triangle, correct? if I said that this is 3 centimeters, this is 5 centimeters, and this is 4 centimeters, what kind of a triangle would it be when we were looking at the side length? Scalene. So right, like this is a right scalene. We can actually give it a name, right scalene. Yeah. Why can't a triangle have more than one obtuse angle? If I ever asked you that. Why can't a triangle have more than one obtuse angle? Yes. What's that, Nathaniel? It wouldn't add up to 180. That's right. Because a 91-degree angle, that's obtuse, plus another 91-degree angle, another obtuse, what would that add up to? 182 degrees. This cannot be, right? Can't be. So the 91 and 91 doesn't work. So you can never have more than one obtuse angle. It's just impossible. Same with a 90. If you had a 90 and another 90, that would already be 180. Okay? So 2 angles add up to 180 already. That cannot be either. Okay, let's put this to the test, what we've learned. Okay? Let's name a few triangles here. Come with me to page 7. Somewhere on this page, one thing I need you to know is when I say classify, I will not necessarily tell you that I'm asking you to name it, but that's what the question is asking you to do. Okay? By side length, what are our choices when it comes to side length? We've got equilateral, we've got isosceles, and we've got scalene. Those are our choices for side length. When it comes to angle measure, what are our 3 choices there? Acute, right, and obtuse. So every triangle should have one from this category, one name from this category, and one name from this category right here. I want you to try. Okay? Page 7, every single triangle, give it a name and a last name. I don't care which one you do first. I honestly don't, as long as it has one from each category. Also go to page 8 and try that as well. Let's see how much you already know without me even teaching you how to do this. Because I know you're smarter than you think. Top of 7, I just remind you a little bit about what you need to classify. Steps to classify: look for side lengths or angles given. It could be markings or actual values. This is on page 7. Second thing I want you to look at is, are you able to determine all 3 angles using the sum of 180? If the answer is yes, you have everything you need to classify and name it. I'm going to hold back with the cosine law there, number 3. Don't worry about that just yet. The first 2, right, look at the side lengths or angles, markings or actual values. And then number 2, are you able to determine all 3 angles using the sum of 180? If it's yes, you have everything you need. Okay? So don't practice yet. Here you go. Let's label, or classify I should say. Over here, in terms of the side lengths, which one would this classify under? Scalene. Yes. So you go scalene. That's the first mark. In terms of the angle, which one would it fall under? Right. You stop looking. If you see the markings, you just say it's a right scalene or a scalene right triangle. Done. Okay? What about this one here? Kenny, do you have a name for it? Bob? Out of this list. Anybody? What is it? No, from this list. Yes. Yeah. Acute equilateral. Okay? Acute equilateral. Or just equilateral, that's fine. Okay? The last one, or not the last one, what would this one be in terms of the side length? What are we told here? These two are the same. So this is an isosceles. Okay? Yeah. Oh, were you raising your hand or were you just itching? Okay. Isosceles and right. Question though, question. Is it possible to find all the angles that you're missing? It is. What do we know if these two sides are the same? What do we know about the angles across from them? Yes. And so let's call this angle A and angle B. I need you to know this skill right here. How would you find the measure of those angles? Angle A would be 180 minus 90, right? And then what are you going to do with what's left over? You're going to split it equally amongst these two. So you go divide it by 2. So angle A is equal to 90 divided by 2, which is 45 degrees. And angle B is also 45 degrees. Okay? So you can check 45, 45, 90. Okay? So that's a skill I want you to know. What about this one here? Does it have markings? No. But it has angles. That's huge. Okay? What is this angle? Let's call this angle A here. Angle A will be 180 minus 30 minus 20. So if you can, do some calculating. So what would that be? 130. Yeah. So now that we know that this is 130, what are we going to call this? Scalene obtuse. Let's focus on the obtuse part first. Why is this a scalene? It is correct, but why is it? If all three angles are different, all three sides will be different. That's all. So, sorry, I have to make this point. Are there any side lengths here? But we still named it by its side length. Like, how is that possible? Because all the angles are different, right? So that's why it is. So the most useful triangle to us in this unit is the one that has all three angles, because we can label it on both sides. The one that has all three sides, there we have to do some investigating. Okay? Okay, I will have an AC on this tomorrow. So I will post the answer key. I'll post the answer key and just try it out. All the way to page 11, I believe.